Okay, let's switch in English because Daniel will present his study from Eurotrading in English. I hope everyone understand. In any case, I'm sure the slides will be self-explained.
Yes.
Please, Daniel, you can take it out mask.
Thank you.
Because everyone is satisfied. Please.
Okay, buongiorno a tutti. Okay, my name is Daniel. I am the CEO of Nanovex INdermal. Okay, who we are? Nanovex is our main company, and we are experts in making drug delivery systems for medical and cosmetic applications. Okay, at Nanovex we develop these drug delivery systems for medical applications, mainly for the treatment of cancer patients and gene therapy, and we have our cosmetic brand INdermal, in which we take this technology and we apply it for cosmetics. Okay, so we take our medical technology, drug delivery technology, and we apply it for cosmetic applications. And what is the drug delivery technology? Drug delivery means the ability to encapsulate drugs or actives into different systems. The most common are liposomes and nanovesicles, and deliver this encapsulated active in different target or tissues. In this picture you can see this is a typical application in medicine, how we are able to release the actives into a cell. But what we do in cosmetics is to take this technology and to apply it, and our targets are different. Our targets are the deep epidermis, the surface of the skin, the follicle, and the hair. What's the benefits of this technology in cosmetics? Okay, the most important is the ability to improve the penetration or improve the efficacy of the actives up to 20 times. Then the second one is the protection of the encapsulated active, because when this active is encapsulated inside of the liposome nanovesicle, we avoid oxidation and degradation process. Then this technology is able to solve different organoleptic problems, and it is very easy to incorporate into the final product. This is our proof. These are the different systems that we have, which we did here was to label these liposomes with a red fluorescent, in this case rhodamine, and we track these liposomes through the skin or through the target, and you can see on your left the liposomes going through the epidermis. The second picture is on the surface of the skin. The third one is the liposomes in the hair, and the last one is concentrated into the follicle. So what we offer is a new generation of nanovesicles made of a medical technology. When I talk about medical technology, it means that we use a formulation with pharma grade, a typical formulation for medical nanovesicles. We are able to control the delivery, not only to place the nanovesicles in a specific target, but we are able to control the release faster or slower. We offer a very high concentration of liposomes, which are related with a very high encapsulation efficacies. They are very resistant and stable. They resist very high temperatures, a wide range of pH, strong agitations. It is compatible with any kind of formula in cosmetics, and one of the main differences is we are able to fuel characterize these liposomes. When we offer these products to our customers, the customer receives all the information about this system, the size, the concentration, all. And what is more important, we are able to make a characterization after adding these products into the final product. So if the customer is worried about what happens with the liposome when these liposomes are added into my cosmetic product, we are able to measure the liposomes in the final product to check the integrity, the concentration, all of them. So we give a lot of confidence to our customer. And now we have developed a vegan version of all of our systems, okay? And here you can see an efficacy study of one of our products. This is the vegan DDS retinol, which means that we encapsulate retinol in a system able to deliver the active into the deepest layers of the skin. And what we measure here is how much improved the penetration into the skin when we compare the free retinol on the right, no, on the left, sorry, with the encapsulated one on the right, okay? After 8 hours, we remove the skin, we separate the layers, we take the epidermis, and we extract the retinol. And we found that in the case of the encapsulated retinol, in the epidermis we found 20 times more of retinol, which is awesome. Then we have other studies like that in which we measure or we compare how much in the aging process our skin lose collagen and elastin. So we want to study how much collagen and elastin we are able to recover because of our retinol encapsulated. So what we do here is to take the skin, normal skin, we age this skin using corticoids. And because of this ages process, the levels of elastin and collagen are reduced, okay? On this skin, we put both free retinol and the encapsulated one. In this case, we compare the vegan version, the normal version. The vegan version is the green one, vegan DDS. The normal version is the purple, DDS retinol, and the free version. And we found that in the case of the vegan version, we recover in only 7 days of treatment, we are able to recover 98% of the lost collagen and elastin in the NG process in only 7 days of treatment. Here you can see our range of products, the typical one. In the case of the DDS, we found different products, retinol, different vitamins, hyaluronic acid, and the surface for the CDS, we found different alpha-hydroxy acids, the follicle one, and the hair care, keratin and panthenol. But our experience and knowledge in this field, in the medicine and in cosmetics, allow us to offer custom designed services. So we are able to offer, in addition to our standard products, we are able to offer to our customers the possibility to make a personalized, a customized products regarding the compound to encapsulate. Maybe the customer wants to encapsulate a special active, extract or protein, and also depending on the target to be delivered. So we are able to make a specific systems for the customer regarding the compound to encapsulate and the target delivery. And that's all from my part. Here you can see the contact or our exclusive distributor in Italy, Eurotrading. And now I'm very happy to answer the questions that you have.
Thanks, Daniel. I'm really appreciate that you cut your few minutes. So thanks a lot. Se avete domande possiamo con piacere coinvolgere la signorina in fondo. Adesso arriva Charlotte con il microfono. Grazie Charlotte. Prego.
So thank you for the presentation, and I have a couple of questions. The first one is, how do you measure encapsulation efficiency? I didn't understand if you do it directly or if you do it indirectly by measuring the product.
Yeah, no, I go directly. What we do is, it depends on the compound, the encapsulated compound, okay? But we do is, we take 2 samples, okay? In one, we remove the unencapsulated compound, so it remains only the encapsulated compound, okay? And the other one, we leave it with the encapsulated and encapsulated, the total active, okay? Then we break the liposomes or the nanovesicles. Depending on the active, we can use detergents or organic solvents. In any case, we break the liposomes, and here we have the encapsulated active release it and give it, and the other side the total active, and then we measure them depending on the active by HPLC or other technique. So we have the concentration of the encapsulating one and the total one. The comparison gives you the entrainment efficiency. Thank you.
Yes, thank you. And the second one is, in your opinion, could it be possible to obtain this kind of carriers by using, for example, atomization or other kind of process? I mean, I think this kind of nanoparticles are liquid, or fluid.
Yeah.
My question is, in your opinion, okay.
Yeah, the atomization is more typical in microparticles instead of nanoparticles. Our manufacturing method is own manufacturing method is special. It's the same that we use in medicine, and this is this manufacturing is divided in 3 steps. But in all the process is liquid. It's a liquid product.
Okay, thank you very much.
You're welcome.
Grazie. C'è qualche altra domanda? Vogliamo approfondire il tema? Prego, Charlotte in fondo, signorina con i capelli rossi. Almeno mi sembra da qui, ma penso di sì.
Just a question. Your technology is also useful for thermolabel molecules.
Yeah, we can encapsulate very different compounds, okay, and we can encapsulate both thermolabel compounds, okay, but in this case, to be honest, the protection is limited because the liposome can protect from light, from oxidation, from interaction between molecules, but in the case of the temperature, if the sample is of 45 degrees, access sample, inside of the liposomes, the temperature will be the same. So if the compound is thermolabel, it is difficult to protect these actives using this technology.
Okay, thank you.
Prego.
Bene, ce n'è un'altra. Abbiamo qualche minuto, quindi approfittiamone.
Thank you for the presentation. It's very interesting.
Thank you.
Is this system stable at high temperature? For example, if I have the need of sterilize the product in a medical device, is stable?
Yeah, this is a challenge. Yeah, it is stable, but it depends. It depends of the temperature and the time. Okay, we have measured that our liposomes resist more or less 80-90 degrees, but only a few minutes, 10, 20. And only a second, resist only a second's temperatures up 100 degrees more or less, okay? More time are linked to change in the morphology of the liposome, and for the reason that the liposomes lose the efficacy. But there are other methods because in medicine and in other applications that we use these liposomes, we make a filtration of the sample with a very small pore size, around 0.2 micrometers, in order to make the sterilization instead of applying head.
Okay, thank you.
Bene. Nessun altro ha curiosità, domande da porre a Daniel, quindi io ringrazio Daniel. Thanks again for the
Grazie.
also in terms of time.